Each transformer must have its own disconnecting means located on the supply side, according to NEC 450.14a. The purpose of this disconnecting means is to safely isolate the transformer from the power source during maintenance, repairs, or in case of an emergency. This is especially crucial for transformers located in areas that are not easily accessible. The disconnecting means must be in a readily accessible location, as stated in NEC 450.14b. Furthermore, NEC 450.15a mandates that the disconnecting means must be within sight of the transformer, or it must be capable of being locked in the open position. To clarify, within sight means visible from the location of the transformer. The requirements are as follows. Firstly, each transformer must have its own disconnecting means, such as a circuit breaker or a fuse switch. Secondly, the disconnecting means must be located within sight of the transformer, meaning it's visible from the transformer's location. Thirdly, the disconnecting means must be readily accessible for maintenance and operation. Fourthly, if the disconnecting means is not within sight of the transformer, it must be capable of being locked in the open position. The consequences of not complying with these requirements can create safety hazards. Firstly, there might be difficulty in isolating the transformer for maintenance or repairs. Secondly, there is an increased risk of electrical shock or fire. Thirdly, there could be an inability to quickly disconnect the transformer in the event of an emergency. To mitigate the risk, you should install a disconnecting means within sight of each transformer. If direct visibility is not feasible, you should install a disconnecting means that can be locked in the open position. In the described industrial facility, with 5 single-phase 37.5 kV solar constant voltage transformers being fed from a 400 amps, 480/277 volts quality manufacturing board load center, each transformer requires its own disconnecting means within sight, especially given their location above the quality control room, accessible only by ladder or scissor lift. Since the quality manufacturing board load center is not visible from the transformer location due to the concrete block wall, the disconnects at the transformers must either be within sight or be lockable in the open position. Let's delve deeper into the NEC articles to further clarify the requirements for transformer disconnects. NEC Article 450 covers transformers in detail, and Section 450.14 specifically addresses the disconnecting means for transformers. As previously mentioned, 450.14 states that each transformer must have a disconnecting means on the supply side. This is not just a general recommendation, it's a mandatory requirement. The disconnecting means must be suitable for the voltage and current involved, and it must be properly rated for the application. Considering the 480 volts/277 volts system in a facility, the disconnecting means must be rated for at least 480 volts. Given that the transformers are fed from 60 amps breakers with 45 amps fuses, the disconnecting means must be rated to handle at least 45 amps continuously. However, it's always best practice to choose a disconnecting means with a higher amperage rating to provide a safety margin and to accommodate any future increases in load. The location of the disconnecting means is equally important. NEC 450.14b states that the disconnecting means must be located in a readily accessible location. This means that it must be easily reached without the need to climb over obstacles or move equipment. The disconnecting means should be installed in a place where it can be quickly and safely operated in case of an emergency. Since the transformers are located above the quality control room, the disconnecting means should ideally be installed near the transformers in that same area. However, accessibility must still be maintained. If the area above the quality control room is cluttered with storage, the disconnecting means must be installed in a way that ensures it remains readily accessible. The within-sight requirement, as outlined in NEC 450.15a, is crucial for safety. The disconnecting means must be visible from the location of the transformer. This allows a person working on the transformer to verify that the power is indeed disconnected before starting any work. If the disconnecting means is not within sight, there is a risk that someone could accidentally re-energize the transformer while work is in progress, leading to serious injury or even death. In the described scenario, since the Quality Manufacturing Board load center is on the other side of a concrete block wall and not visible from the transformers, simply using the breakers in the Quality Manufacturing Board load center as the disconnecting means would not meet the code requirement. Each transformer must have its own dedicated disconnecting means that is either within sight or lockable. The lockable in the open position provision is an alternative to the within sight requirement. If it's not possible to install the disconnecting means within sight of the transformer, then the disconnecting means must be equipped with a locking mechanism that can be used to secure it in the open position. This ensures that the disconnecting means cannot be accidentally closed while work is being performed on the transformer. The locking mechanism must be substantial enough to prevent unauthorized operation, and it must be designed in such a way that it cannot be easily bypassed. When using a lockable disconnecting means, it's important to establish a clear lockout/tagout procedure to ensure that all personnel are aware that the transformer is de-energized and that it should not be re-energized until the work is completed. The procedure should include steps for verifying that the power is indeed disconnected before starting work, and for testing the transformer to ensure that it is safe to handle. The NEC also addresses the type of disconnecting means that can be used for transformers. While a circuit breaker or a fuse switch are the most common options, other types of disconnecting means may also be acceptable, as long as they meet the requirements of the NEC. The disconnecting means must be rated for the voltage and current involved, and it must be capable of interrupting the full load current of the transformer. In addition to the general requirements for transformer disconnect, the NEC also has specific requirements for certain types of transformers. For example, Section 450.3 addresses the overcurrent protection requirements for transformers, and it specifies the maximum size of the overcurrent device that can be used to protect a transformer. Section 450.13 addresses the grounding requirements for transformers, and it specifies the methods that can be used to ground a transformer. These specific requirements must be followed in addition to the general requirements for transformer disconnects. In summary, providing a disconnecting means within sight of each transformer or a lockable disconnect is essential for ensuring safety during maintenance, repairs, and emergencies. Failure to comply with these requirements can lead to serious hazards, including electrical shock, fire, and even death. By following the NEC guidelines and implementing proper lockout/tagout procedures, you can significantly reduce the risk of accidents and create a safer working environment. Now, let's consider some practical solutions for installing disconnecting means for the transformers in the described facility. Given the location of the transformers above the quality control room, and the fact that the Quality Manufacturing Board load center is not visible from that location, the best approach would be to install dedicated disconnecting means for each transformer near the transformers themselves. Since the area is accessible by ladder or scissor lift, the disconnecting means should be installed in a location that is easily reached from either of these platforms. The disconnecting means could be mounted in the wall near the transformers, or on a nearby support structure. The disconnecting means should be clearly labeled to identify which transformer it serves. The label should be durable and easy to read even in low light conditions. If it is not possible to install the disconnecting means within sight of the transformer, then lockable disconnecting means should be used. The locking mechanism should be robust and tamper resistant, and it should be designed to accept a standard padlock. A clear lockout/tagout procedure should be established and enforced to ensure that all personnel are aware of the importance of locking out the disconnecting means before working on the transformer. The procedure should include steps for verifying that the power is indeed disconnected before starting work, and for testing the transformer to ensure that it is safe to handle. In addition to the disconnecting means, it's also important to ensure that the transformers are properly grounded. The grounding conductor should be sized according to the NEC, and it should be connected to a suitable grounding electrode. Proper grounding helps to prevent electrical shock and reduces the risk of fire. It's also important to ensure that the transformers are properly ventilated. Transformers generate heat during operation, and if they are not properly ventilated, they can overheat and fail. The area around the transformers should be kept clear of obstructions to allow for adequate airflow. If necessary, fans or other cooling devices can be used to improve ventilation. Finally, it's important to regularly inspect and maintain the transformers and their disconnecting means. The inspection should include checking for signs of damage, overheating, or corrosion. Any problems should be corrected promptly to prevent further damage or safety hazards. The disconnecting means should be tested periodically to ensure that they are functioning properly. The testing should include verifying that the disconnecting means can interrupt the full load current of the transformer, and that the locking mechanism is working correctly. By following these practical solutions and implementing a comprehensive maintenance program, you can ensure that the transformers in your facility are operating safely and reliably. Remember, electrical safety is paramount, and it's always best to err on the side of caution. If you're not sure about something, consult with a qualified electrician or electrical engineer. They can help you to ensure that your electrical system is compliant with NEC and that it is safe for your employees and your equipment. When selecting the disconnecting means, consider the environment in which it will be installed. If the area is dusty or damp, choose a disconnecting means that is designed for those conditions. If the area is subject to vibration, choose a disconnecting means that is built to withstand vibration. The disconnecting means should also be sized appropriately for the load it will be serving. The amperage rating of the disconnecting means should be at least 115% of the transformer's primary current. This will provide a safety margin and help to prevent nuisance tripping. It's also important to consider the interrupting rating of the disconnecting means. The interrupting rating is the maximum amount of current that the disconnecting means can safely interrupt. The interrupting rating should be high enough to handle the available fault current at the location where the disconnecting means is installed. A qualified electrician can help you to determine the available fault current and to select a disconnecting means with an appropriate interrupting rating. Once the disconnecting means has been selected, it should be installed according to the manufacturer's instructions and in accordance with the NEC. The installation should be performed by a qualified electrician who is familiar with the NEC requirements for transformer disconnects. After the disconnecting means has been installed, it should be tested to ensure that it is functioning properly. The testing should include verifying that the disconnecting means can interrupt the full load current of the transformer and that the locking mechanism is working correctly. The results of the testing should be documented and kept on file. In addition to the disconnecting means, it's also important to consider the overcurrent protection for the transformer. The NEC requires that transformers be protected by overcurrent devices, such as fuses or circuit breakers. The overcurrent devices should be sized according to the NEC, and they should be located on the primary side of the transformer. The overcurrent devices should be chosen to protect the transformer from overload and short-circuit currents. They should also be coordinated with the disconnecting means to ensure that the disconnecting means can safely interrupt the fault current. Proper overcurrent protection is essential for preventing transformer damage and electrical fires. It's also important to consider the grounding of the transformer. The NEC requires that transformers be grounded to provide a low impedance path for fault currents. The grounding conductor should be sized according to the NEC, and it should be connected to a suitable grounding electrode. Proper grounding helps to prevent electrical shock and reduces the risk of fire. Finally, it's important to remember that electrical safety is an ongoing process. Regular inspections and maintenance are essential for ensuring that the electrical system is operating safely and reliably. The inspection should include checking for signs of damage, overheating, or corrosion. Any problems should be corrected promptly to prevent further damage or safety hazards. The disconnecting means should be tested periodically to ensure that they are functioning properly. The testing should include verifying that the disconnecting means can interrupt the full load current of the transformer and that the locking mechanism is working correctly. By following these guidelines and implementing a comprehensive maintenance program, you can ensure that the transformers in your facility are operating safely and reliably.